In this video, we will solve further problems from exercise 3.4. Question number 13. Show that tan 75 plus cot 75 is equal to 4. Our tan 75 degrees can be written as tan 45 degrees plus 30 degrees. So now applying tan alpha plus beta, this becomes tan 45 degrees plus tan 30 degrees divided by 1 minus tan 45 degrees into tan 30 degrees. So further applying or replacing the values of tan 45 and 30, we get this to be 1 plus 1 by root 3 divided by 1 minus 1 into 1 by root 3. We can further rewrite this as root 3 is the denominator, common denominator for the numerator. So let's call this root 3 plus 1 divided by root 3 for the numerator. And similarly, the denominator will be root 3 minus 1 divided by root 3. So that's equal to root 3 plus 1 divided by root 3 minus 1. Therefore, our cot 75 degrees will be equal to 1 by tan 75 degrees. So we already found our tan 75 degree as this. So this would be just the reciprocal of this. So it will be root 3 minus 1 divided by root 3 plus 1. Therefore, our LHS now becomes, which is tan 75 degrees plus cot 75 degrees is equal to tan 75 degrees is root 3 plus 1 divided by root 3 minus 1 plus root 3 minus 1 divided by root 3 plus 1. So simplifying this, our denominator will now be root 3 squared minus 1 squared. Multiplying these two terms, then the numerator will be root 3 plus 1 the whole squared plus root 3 minus 1 the whole squared. So further expanding this will be 3 plus 1 plus 2 root 3 plus 3 plus 1 minus 2 root 3 divided by 3 minus 1. So that would be 3 plus 1 is 4. These two terms will disappear. So it's 8 divided by 2, which is equal to 4. That's equal to our right hand side. Hence the proof. Question number 14. Prove that cos A plus B into cos A minus cos B plus C into cos A is equal to sin B into sin C minus A. Let's take the left hand side first. So the left hand side is equal to cos A plus B cos C minus cos B plus C cos A. So let's expand these two terms, cos A plus B and cos B plus C. So cos A plus B will be cos A cos B minus sin A sin B into cos C minus, again expanding cos B plus C, we get cos B cos C minus sin B sin C into cos A. Then let's multiply cos C with the each individual terms inside, and similarly cos C here. So this would become cos A cos B cos C minus sin A sin B cos C minus then cos A into cos B into cos C will be cos A, cos B, cos C, minus into minus will be plus cos A, sin B, sin C. Now these two terms will disappear, so you'll be left with cos A, sin B, sin C minus sin A, sin B, cos C. Now you can see that sin B is common for both. So let's take sin B out. So sin B into cos A sin C minus sin B, if you remove it, this becomes sin A cos C. This is nothing but sin C minus A. So this is equal to sin B into sin C minus A. That's equal to RHS. Hence the proof. Question number 15. Prove that sin n plus 1 theta into sin n minus 1 theta plus cos n plus 1 theta into cos n minus 1 theta is equal to cos 2 theta. So let's take A as n plus 1 into theta and B as n minus 1 into theta. And let's substitute this on the left hand side. So the left hand side will now become sin A sin B plus cos A cos B. This is in the form cos A minus B. So this is equal to cos A minus B. Further, let's substitute the values of A and B into this. So this becomes cos of A is n plus 1 theta and B is minus of n minus 1 theta. So expanding the terms inside, this becomes cos n theta plus theta minus n theta, and minus into minus will be plus theta. So that's equal to plus and minus n theta will disappear. So this will become cos theta plus theta will be 2 theta, which is equal to RHS. Hence the proof. Question number 16. If x cos theta is equal to y cos of theta plus 2 pi by 3 is equal to z into cos theta plus 4 pi by 3, and find the value of xy, yz and zx. So let us define k to be equal to each of these terms. So we can say that x cos theta is equal to y cos theta plus 2 pi by 3 is equal to z into cos theta plus 4 pi by 3 is equal to k. Let's just assume k. Then what we can say is cos theta will be equal to k divided by x. Therefore, our k by x will be equal to cos theta. Similarly, our cos theta plus 2 pi by 3 will be k by y. So k by y will be equal to cos theta plus 2 pi by 3, and our k by z will be equal to cos theta plus 4 pi by 3. So k by z is equal to cos theta plus 4 pi by 3. Therefore, our k by x plus k by y plus k by z will be equal to cos theta plus cos theta plus 2 pi by 3 plus cos theta plus 4 pi by 3. Let this be equation 1. So, LHS of 1 is equal to k by x plus k by y plus k by z. You can write that as the denominator x, y, z into k times yz plus k times xz plus k times xy, which is equal to, if you take the k out, this will become k into yz plus kxz plus xy divided by x, y, z. So let's call this 2. Now the RHS of 1 can be written as cos theta plus our cos theta plus, let me replace pi with 180. So this becomes 2 into 180 degrees by 3 plus cos theta plus 4 into 180 degrees by 3. Now 180 degrees with 3 will be 60 degrees here, and this will be 60 degrees. So this is equal to cos theta plus cos theta plus 120 degrees plus cos theta plus 240 degrees. So this becomes cos theta plus, expanding this will become cos theta cos 120 degrees minus sin theta sin 120 degrees plus cos theta cos 240 degrees minus sin theta sin 240 degrees. Let's calculate the values of cos 120 and sin 120. So sin 120 degrees will be equal to sin 90 degrees plus 30 degrees. Now since sin is positive on the second quadrant, this will be equal to cos 30 degrees. Similarly, our cos 120 degree will be equal to, cos is negative in the second quadrant, so this will be minus sin 30 degrees, and our sin 240 degrees can be written as sin 180 degrees plus 60 degrees. And in the third quadrant, sin is negative, so this is minus sin 60 degrees, and cos 240 degrees will be equal to, cos is negative, so in the third quadrant, so it's minus cos 60 degrees. Now let's apply those values onto this equation here. So this will become cos theta plus cos theta into cos 120 is minus sin 30 degrees. So sin 30 is 1 by 2. So this is minus 1 by 2. Then minus sin theta into sin 120 is cos 30 degrees. So which is root 3 by 2. Then you have plus cos theta into cos 240. Cos 240 is minus cos 60 degrees. So this is minus 1 by 2 minus sin theta into sin 240 is minus sin 60. So it's minus root 3 by 2. So Further simplifying this becomes cos theta minus half cos theta minus root 3 by 2 sin theta minus half of cos theta plus root 3 by 2 of sin theta. So these two terms will disappear. Cos minus half of cos theta minus half of cos theta will be equal to 0. Therefore, from 2, let's call this 3. From 2 and 3, we can say that k into yz plus xz plus xy divided by xyz is equal to 0. So now taking xyz to the other side and k to the other side, this will become, and let's rearrange this, xy plus yz plus, we can rearrange the xz as zx. Since we take xyz to the other side, this becomes 0, and k also, when you divide 0 by k, will be 0, is equal to 0. And this is our value of xy plus yz plus zx. Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.